Hey, it's me and Mr. McKenzie, Mr. Romanovich, Mr. McKenzie. We're going to be comparing and ordering rational numbers today. So get the standard down, and by the end of this, you should be able to say, I can compare and order rational numbers by making them into decimals and using a number line.
So it's a mouthful, but we'll be good at it by the time we're done. All right, here's our first ones. In order to compare rational numbers, remember rational numbers are decimals and fractions. Anything that can be written as a fraction, just with their negatives mixed in there. We're going to use a number line in order to compare them, to decide which one is bigger or smaller. So here we want to do negative 1.2 and 0.8 or 8 tenths. So we're going to put those on our number line. It can be a real basic number line here. So let's go, since we're doing 8 tenths and 2 tenths, let's count by tenths. Or no, we're going to count by 2 tenths, right?
2 tenths.
All right, I forgot. So 0.2, 0.4, 0.6. That was really a point there, sorry. 0.8. Wow, that's awful. Mr. Romanovich's bad luck. It's somehow his fault.
I am bad luck.
I don't know why it's his fault, but I'm going to say it's his fault. 0.8.
Shaking the table.
1.0. Then in the opposite direction, we're going to count down in our negative. So negative 0.2. Here I did want my negative and my point. Negative 0.6. Negative 0.8. Negative 1.0. And then a number line that can always get a little longer, negative 1.2. We place our numbers on our number line. So here's negative 1.2, even if you can't really read my writing that says it's there. 0.8 or 8 tenths is over here. And then remember, whichever number is farther to the right is the larger number. So 0.8 or 8 tenths is greater than negative 1 and 2 tenths. All right, you get the next one. It shouldn't be quite as bad as mine.
So the next one, we see our numbers as negative 1.40 and negative 1.25. So let's do them by 5/100ths apiece. So if we start at the right, we'd start with negative 1.20 and then negative 1.25. So we're going down 5/100ths each. And then negative 1.30, negative 1.35, and negative 1.40. Would you do one more?
I would. I don't like my number line to end at my last number there.
Then we find on our number line negative 1.25, which is just to the left of negative 1.20. And then the negative 1.40 is right there. And we know as we go towards 0, the numbers get larger, which means the number on the right is the larger of the two. And also, as they're written, the number on the right was the larger of the two. So negative 1.5 was larger than negative 1.4.
So as you're setting up your number line, try to think about what could I count by to make sure we hit both of those numbers as we're going. And then make sure you span a large enough distance so that both of those numbers will fall into that gap or into that space for you. Next one. Now we're going to compare rational numbers, but this one isn't playing nice. He's a fraction instead of a decimal. So remember last unit, we can change that fraction into a decimal. When everything's the same form, it's much easier to put them on our number line. So we have negative 8/15. There's no easy way to turn a 15 into a 10 or a 100. So this is one of those where we have to divide. Remember our NIDO, numerator inside, denominator outside. So 8 goes on the inside, 15 goes on the outside. I know I'm going to have to put in my 0 in my decimals because that just always happens. So 15 goes in 0 times. Into 80 it goes in 5 times, which is 75. Subtract to get a 5, bring down my 0. 15 goes into 50 3 times, which is 45. Get a 5, add a 0, bring it down. You're probably already noticing what's happening. 15 goes into 50 3 times, which is 45. I get a 5. Notice, same pattern. We're going to have a 5, bring down a 0. So we are repeating that 3 in our number. So negative 8/15 is really, remember, negative just kind of tags along. 0.53 repeating. So Mr. Romanovich, why don't you talk us through setting up our number line now that they're both decimals?
So we'll start, since we're going by, we'll go by hundredths here, and since they're a 1 and a 3, we'll go by 1/100th each. So if we start at 0.50 and then go to the left, and we'll decrease it, technically, by 1/100th each time, we can start to see exactly where we're at. So then we have a 0.53, a negative 0.54, and a negative 0.55. And once again, we know that the farther to the right we go, the larger the number. And as we place these points, you've got a negative 0.51 there, and a negative 0.53 repeating, so that's just a little past the 0.53, the negative 0.53.
Kind of put a little bit past there just as an estimate for us.
So as we look at that, then the larger of the two would be the negative 0.51.
So that one is the
Greater
larger.
than sign.
It's going to take a little bit of time to kind of figure out what to count by. It's going to take a little trial and error, and that's something we'll practice in class. But just kind of think about, what do I need to hit to make sure my numbers will fit on my number line?
Then for this, the key for this is making sure they're all in the same form. And for us, what we're doing is we're turning them into decimals. And the problem's given us some pretty good fractions to work with here too. So we have negative 2.46. Then our next one is negative 2 and 22/25. Well, we know 25ths can convert very easily into hundredths, so we'll just multiply top and bottom there, numerator and denominator, by 4, giving us negative 2 and 88/100ths, which would then turn into negative 2.88. Likewise, negative 2 and 1/10, there we're doing multiply a numerator and denominator by 10, giving us negative 2 and 10/100ths, or negative 2 and 1/10.
I was a little behind here.
That's okay. And then we'll keep that 0 there just to keep our justification. So we've got the same length of numbers there. Then as we lay these out, I think what we should do is probably start at 2, negative 2, and we'll go to negative 3. And let's just do it by tenths. Let's see if we can compare it that way. So negative 2/10, negative 2, negative 2 and 1/10.
Okay.
There we go. Negative 2 and 2/10, negative 2 and 3/10, negative 2 and 4/10. You're all guessing what the next one is. Negative 2 and 5/10, negative 2 and 6/10.
They're trying to see if Mr. McKenzie can
Negative
keep
2
up without making it look
and
awful to read.
7/10, negative 2 and 8/10, negative 2 and 9/10.
Then negative 3.0.
3.0.
And if we want to, since our numbers all had 2 decimal places, we could very easily make each of these into something with 2 decimal places, just to make our comparisons a little easier. I didn't think about that ahead of time.
Well played, Mackenzie.
Remember, we can add a 0 at the end of it without affecting the number. And now we're going to place these. Here's the easy one, negative 2 and 1/10. That one's right there on my
Perfect.
number line. Negative 2.88. Well, that's going to be between 80 and 90. It's going to be closer to the 90 area here. So I'm going to estimate it to be about there. And then negative 2.46. That's between my 40 and my 50, a little over halfway. So again, you're just kind of estimating where they're going to fall on the number line. And then now we can put them in order.
I really like the way Mr. McKenzie actually said that. If you're thinking about like negative 2.88, that falls between 80 and 90. You know 0.88 falls between 80 and 90. And that's a very easy visual that you can see. 2.80 and 2.90. You see the 80 and 90 there. Sometimes getting that out of your mouth and out of your head can help you put it on the line a little bit better than just assuming, going back to that right side thinking where you're thinking that 2.88 would be to the right of 2.80, when in reality on the left side of the number line, it is on the left side of it.
Yeah, it's very tough to kind of train your brain to think backwards on the negative side. And then our last step is write them from least to greatest. Remember, that's how our number line is set up. It's already in order from least to greatest. Negative 2.88, negative 2.46, and negative 2.10. And it's okay to leave them in their decimal form since we know where they came from originally. Or hopefully Mr. Romanovich is okay with that.
Yeah, we'll see.